Hey everyone, and welcome back to Peanut Workshop. If you're new here, we designed a custom motor controller for our kids' ride-on toys. Specifically a kids' tracks police car, Power Wheels Dream Camper, this Lightning McQueen. This is not the one that's so desirable, but we do have it, and that's one that we're going to be modifying soon. We have a Bravo Grave Digger and a Prego tractor. All of those have been modified with our custom speed controllers, and that's what we use to test our controllers before we sell them. So today we're introducing our most advanced controller yet, the DRV245BD V6. So that's going to be the version 2. There was a version 1. The version 1 is actually what you see here. Right here it says V1 in the corner of the board. V2 is being delivered soon. And that's the one that we're hoping to start offering for sale. So where we started about a year ago modifying our son's police car. He wanted a police car for his birthday, and we didn't want to give him just the standard on-off. We wanted variable speed, and we wanted to be a little faster. So we know Traxxas from RC cars, so we put Traxxas 550 motors in it and a little speed controller with a variable pedal we found on Amazon that was relatively cheap, and it worked okay. Shortly after we installed it, we started to realize that there's a lot of loss in it. As soon as you put heavier kids in the car, it would overheat and start losing a lot of voltage. There seemed to be a lot of voltage drop once the load started increasing. So we weren't too happy with the performance, and it was fine. It was fine for the police car. Usually it was just our son. It was for his 4th birthday. So not too heavy, but we had the Barbie Dream Camper that we wanted to modify too. And that one was heavy. That car can fit 4 kids in it surprisingly easily when they pile in the back. So that one needed a bit beefier of a speed controller. We started with some other off-the-shelf options. There's a write-up on the peanutworkshop.com website. You guys, if you're interested in the backstory, go read that. But where we're going to start is we're going to kind of start with the version that we started selling, which is version 6, and outline the issues that people had with it and we had ourselves, and kind of, you know, we did end up creating a version 7 here. There were some issues with that one. Actually, the only issue with that was actually production. And then we decided to step it up a little bit and go with a new version, make some more drastic changes, and call it a new name, because it was pretty substantially different. This one looks very different and looks similar to this one, but it's almost identical functionality between the version 6 and version 7. It's just a different form factor to make the enclosure much more protective. So what did we get right with the original design, the 230? We did 6 design iterations. Version 6 is the 6th version of the board we had built. So it did take a while to work out all the different bugs. This was the first motor controller I ever designed, so you'd expect there to be quite a few iterations. So it did work really well up to about 40 amps. These connectors are rated for 41 amps continuous. So that was kind of the limiting factor. The board itself wasn't. The board itself could keep going pretty high into the 60 amp range. But those connectors do start to melt around 40 amps, just over 40 amps. Anyone using the version 6, do try to keep that current under 40 amps. So it was a dual brushed motor controller that offered forward, reverse, and a variable brake. That's what we were looking for the most. We wanted to bypass all the internal wiring of the vehicle, but still use all the stock features. That our son really wanted to keep all the original features. He wanted the original gear shifter. He wanted the original sounds, all of that, and that's what we did. So that's kind of where it went right. Where it went wrong is we used some pretty low quality components trying to save costs. our target price point was much lower than where we are. Unfortunately, to make it reliable and not waste people's time, we had to go with much higher quality components. So we replaced the 12-volt supply. So there is a 12-volt output to power the stock accessories, lights, sounds, stuff like that. And that kept failing. So the original version, we had a max of 40 volts, and everything was rated for higher than 40 volts. There wasn't enough derating though, and we kept burning up that 12-volt power supply for anyone operating pretty much over 35 volts. It was about a 50% failure rate. The 5-volt power supply had a handful of failures, not many, but we did replace that as well, just because the couple failures we did have were suspected to be due to using lower quality components. So that's been replaced with a much more reputable brand. Another change we made that's big for us is we added a quick connection here so that we can test each unit much faster. I just can plug in, run through my test procedure, and unplug it versus going through it and pushing all these spring cage clamp connectors down. And that kind of leads us into the next big issue, is these would break. Like, you snap them and they would end up breaking. So we did have some failures with these lever connectors as well, and we wanted to replace those with something that we thought that would be more reliable. We like the ease of use of the lever connectors and these spring clamp connectors as well. However, we felt that going with a screw terminal was going to just be a more reliable option. It takes a little bit more time to install the unit, but overall, you do end up with a better connection. So, new version. So these enclosures aren't screwed together. There are 4 screws that come in the bottom. These will be assembled before we ship them. So these are 6-gauge connectors rated for 65 amps. That's what we switched to. We thought that overall that was going to be a more fitting termination. Closure was an afterthought. I was just installing the bare board in my kids' cars, and there was a lot of interest. A lot of people wanted the custom speed controller as well. So we started selling it and kind of came up with an enclosure later. I had a very bulky one originally and then started 3D printing these with these are printed out in a flame retardant polycarbonate. There's one indicator on the board that is an enable indicator. That just means the motor drivers are enabled. So that means motor A and motor B are able to drive. There's a few reasons that indicator might be off. One is it's not working. The other is you've hit your low voltage, under voltage protection. If you hit that, this will still be on, but that LED will be off. You'll still be able to connect to the Wi-Fi. And basically, if you can connect to Wi-Fi and that LED is off, that means you're probably under the voltage threshold. One of the most common things people are asking for is just a higher voltage. So this one was 35 volts. They wanted to run 2 drill batteries in series. That's the most common. There was a few people asking for like 48 volts. 12S lithium ion or lithium polymer. That was just a little bit too high. We couldn't do that with this design without major changes. So 42 volts is the maximum. That's 10 series lithium ion or lithium polymer cells. So that's going to be good for any 36 volt lithium battery pack or a lead acid battery pack. So if you have 20 volt DeWalt batteries, 20 volt or 18 volt drill batteries, you can put 2 in series and run just fine. There aren't many motors that are going to survive that, but you can run that high of a voltage, and this is going to last no problem. All the components have been upped for their voltage rating. That was the main reason for designing a new 12 volt power supply, was just to be able to run that 42 volt maximum input voltage. Another big thing is a lot of 4-wheel drive units and a lot of cars with 2 motors per gearbox. Each of these connections is rated for 65 amps on the connector. Board, no, but the connector, yes. So you're not going to damage the connector. You should be able to put as much current as this board can put out through these connectors without any failures there. But you can wire 2 motors per connector pretty easily. You know, so 2 on channel A, 2 on channel B, and drive 4 motors for a 4-wheel drive unit, or if you're running dual motors per gearbox. One of the biggest issues I had as the designer of the board with the original, the version 6, is the current sensing capability. The current sensing capability was kind of a afterthought that I came up with, and I didn't use really the correct components. I didn't use proper current sensing ICs, and it wasn't very accurate. So I put a proper current sensing IC is an integrated circuit, on the board, and that's what's measuring the actual current through each channel. So that's now accurate to about 1 amp, and that's good up to 53 amps. So I wanted it up to 60. Calculation must have been a little bit off, but it does measure within 1 amp up to 53 amps. And I haven't had any issue with that in any of my testing. It seems to always across the board measure up to 53 amps at 1 amp increments just fine, and it matches my clamp. Do you need a fan? No, you don't need a fan. If you're running a single 775, 550, 887, or 895 motor, you're not going to need a fan. That's single motor per channel. So 2 motors total, 1 per channel. You don't need fans. You're good up to 50 degrees Celsius ambient. You know, that's, you know, well over 100 degrees Fahrenheit. And this is going to operate well below the thermal limits. Once you add a second motor in there of that set, you know, second 550, a 775, 887, or an 895. So for anyone who doesn't know, that references the can size of the motors. You're going dual 775s like a lot of people do, like Andy Mark or Vex Pro 775s. Basic 40 millimeter by 10 millimeter fans just like this is going to be perfectly fine. You'll be well under the thermal limits. You shouldn't have to worry. You're going to want to keep them clean and make sure they keep running, but you're not going to run into an issue. If you're doing something even more extreme where you're pushing the limits, you're going maybe over 50 amps, you might want to invest in some Noctua 20 millimeter thick fans. These did drop the thermals by about 10 degrees Celsius, switching from these fans to these fans at high loads. Yeah, that was 50 amps range. I did some current testing with up to 80 amps per channel. That was good for about 30 seconds to a minute, you know, for a peak current rating. So I started with no fans just to kind of see how it would do for thermals, and it didn't do well enough. So I added a single fan here just to see how much it would improve, and if I would need 2. You know, my kind of my thought was it would blow it in and then kind of blow it across, you know, blow it on channel A here and then kind of go that way and cool both channels. It did, but channel B was still getting really hot. Channel A was nice and cool, but channel B was still getting pretty warm. So I was like, all right, let's see if we can fit a second fan. And we could. We had to squish the words a little bit, decrease the font size, but it did fit. We went with 2. I would install 2. And these are 12 volt fans. I recommend running it off the 12 volt. Don't run it off the 5 volt. You could run it off 5 volt. You know, you could get 5 volt fans and run it off 5 volt. I think it would be fine, but the 12 volts is going to be a little more efficient. So you run it off the 12 volts. I'm going to go do a little bit deeper dive into this board. If you're familiar with this one, there aren't many changes as far as the real functionality. I've kind of already hit on that. So this is more for people who aren't familiar with the older version, didn't use it. This is a dual channel speed controller. So the channel A, channel B with a max voltage of 42 volts. I put that right on the enclosure to try and keep people from exceeding that 42 volt limit, because it will cause damage around 44 volts. There is a circuit to discharge high voltage, and that's intended for if you don't have a battery plugged in, you have it turned off, you're pushing the car, it's going to build up a lot of voltage, so there is a circuit to discharge that. That circuit's only meant to discharge pushing a car with no battery that's turned off. It's not meant to discharge a battery plugged in that's too high of a voltage. So do not exceed the 42 volt limit. You will run into issues with it failing. Current rating, voltage and current rating, 2 most important characteristics of the board. I hit on it. You know, 45 amps, that's where the 245 is. It's two 45 amp channels and it's a brushed motor controller. That's kind of what that name means. This was designed around 45 amps per channel. So two channels at 45 amps, 90 amps total between both channels. And if you are going in the 40 amp range, you are going to want to run at least two of these smaller, cheap fans just to keep it cool. And that's 45 amps continuous power. So that continuous really means the average power that this board's putting out per channel is 45 amps. So if you open up the app and you see it going from 30 to 45, 30 to 45, you're fine with no fans. If you see it going 40 to 50, that range, you might want to put some fans on it. And remember, the current is going to limit, the max reading is going to say 53 amps. So just keep that in mind. If you're seeing 53 amps, you're probably higher than 53. Good rule of thumb, averaging 35 amps, no fans. Averaging 45 cheap fans. If you're averaging in the 50s, go with the Noctua fans. I didn't do extensive research on fans. You may be able to find cheaper high performance fans. These power connectors, I want to note that these power connectors, there are two terminals for the plus, two terminals for the negative. These are wired in parallel, so you don't need to connect both. If you're running a lower power application like single motor per channel, you only need to connect one. You know, one positive, one negative, and it doesn't matter which one you connect to. You can connect to either. And when you are connecting this, always make sure that you are using proper overcurrent protection on your battery. You either put a fuse in or a breaker, sized appropriately. For the single big motors, I usually end up going with a 50 amp automotive fuse, and that's usually what's needed to keep those from blowing. So if you're going with 4 motors, you're going to need probably 2 battery packs with a 50 amp fuse each to keep it going. So keep that in mind. One of the cool features that people really like, and I really like, is the ability to access this with any Wi-Fi device. So you don't need an app of any kind. It uses a Wi-Fi access point, and you just connect to the default network is speed control. So you go to Wi-Fi, connect to speed control, enter the password. The password's right here on the cover, speed control. That's the default password. You can change both the password and the network ID once you're logged in. And then you go to any browser and you type in 4.3.2.1. It's very similar to logging into any router that you may have set up. And once you type in 4.3.2.1, you're going to access the web page that's run locally on this device. In there, you're going to be able to configure all kinds of different parameters, timings, your low voltage cutoff, if you have a throttle pedal, if you have a brake pedal, and you're going to be able to see all the diagnostics. You're going to be able to see if it's in forward high, forward low, neutral, stuff like that. None of those features have changed. There's no change to the software between this version and this version, except for low-level changes just to make it work. All right, let's go over the logic input. So I consider this part the logic and this the high power. Note that the V in plus, you have on and plus 12, that's not really logic, but I put it on the logic side of the board because that's kind of what it is with very low current, very high current. So that's why it's separated like that. So V in plus is what it sounds like. That's the positive input voltage. So that's this goes through a protection diode into here and then on. So you put a jumper here. It's going to come with a jumper pre-installed, and I recommend you put a switch in just so you can turn it on and off. You don't need to. I rarely wire them in for my kids. But all of any current used on the logic side, so if you have, it includes the plus 12 and the 5 volt output, is going to go through that. So if you have, anything remotely high power connected to that, just use appropriately sized wire. Now, 12 volt is limited to 3 amps. After 3 amps, there's a thermal fuse that will trip and you will lose that 12 volt output. So you really are limited pretty much to 3 amps going through here, but keep that in mind. So that's how you turn it on. You will not see this LED without a jumper wire connected in here. These are relatively small terminals, so you may run into issues using the stock wiring without stripping it down a bit and getting rid of some of the copper strands in the wire to get it to fit in those terminal blocks. Sometimes I have to, sometimes I don't. I believe that it is a 12 gauge connector, so it's like 22 to 12 gauge is the size, recommended size wire, but it is, you know, stranded 12 gauge is hard to get it in there without having stray strands going, you know, crossing. You want to make sure you don't have any strands going from on to plus 12, for example. You could cause damage there. All right, next one is B negative. So a lot of applications, you're going to connect the plus 12 and B negative just to the original vehicle's power input. You know, if it's 12 volt vehicle, you're just going to now say, hey, here's 12 volts out of the controller and the negative side. And then you're going to use the plus left, plus right, minus right inputs, and those are the inputs out of a standard Power Wheels like gear shifter into the stock motors. So you're going to cut the stock motor wires and connect it into those terminals, and that's going to, the logic and the board is going to detect if it's in low, high, or reverse. So that's really the easiest way to plug it in. You really need those 6 connections, and you can be up and running if you don't want to wire a throttle pedal. Now I have plus 5 volts and battery negative here. This 5 volts, I don't have any use for it. You probably don't need it. I wired it out because it was available. And then T is for throttle. That's the throttle pedal. That takes a maximum of 3.3 volts. So anywhere from 0 to 3.3 volts, and that gives you your variable speed. From 0 to 2.7 volts, you'll get a 0% power to 100% power. So 2.7 to 3.3 is all 100%. That just gives us some tolerance. And you can adjust that in the software if for whatever reason you're using a throttle pedal that doesn't quite read 100% when it's pushed all the way down. You can adjust that in the software to calibrate it. All right, so then we have 3.3 volts. That's intended to be used for throttle and brake pedal. That's a very low power 3.3 volts, so don't be connecting it to anything that draws power. It's just meant for logic use only. And then you have the B negative connection intended for the throttle and brake pedal. These are all the same B negative. You can use whichever one you want. I added a couple from this version just because it was kind of annoying not having enough and trying to shove all the wires into one terminal block or using a Wago lever nut. So BR, that's brake pedal. So that's the same as the throttle, 0 to 2.7 volts. That'll give you 0 to 100% brake. And brake is disabled by default. Throttle is enabled by default. Because if throttle wasn't enabled by default, as soon as direction's detected, it takes off. So that's why the throttle pedal is enabled by default. So if you're not using a throttle pedal, you want to just use it as a soft start, soft stop, you're gonna have to go in and disable the throttle pedal in the software before it's going to work. All right, then we have FH for forward high, FL for forward low, and R for reverse. These get pulled to B negative through a switch contact. So you could use either these 3 inputs for forward high, forward low, or reverse. You don't have to use forward low if you don't want. I usually don't wire it up. Or you can use these. Don't use these and these or some mixture of this. It's not going to work. Don't even try. I don't know why you would. Either use these or these. So these are easy. You just connect a switch to battery negative to here. When the switch is on, it's going to detect it. It's going to pull this pin low. So this pin is pulled high to 3.3 volts on the board. And we connect B negative, it pulls it low. So that's how the direction works. Never put any voltage on forward high, forward low, or reverse. Those are pulled to B negative only. You can burn it up if you try to put power in it. I didn't mention that these 4 inputs, these all reference 12 volts. So if you try to use it with a 5 volt with 3.3, it's not going to work. If you try to use it with 3.3, it's probably going to burn up the 3.3 volt power supply. Follow the installation guide. All right, then we have a 34 and a 35. These are just unused inputs. There's no functionality associated with those whatsoever. It's in case I wanted to add features at some point down the road. They're available and I can. And then you have RST. That's reset. So if you forget your password, good news, you can reset it. You have to follow the instructions. You have to pull it. I forget if it's 3.3 volts or battery negative, but you connect it to one of these 2 terminals on boot up, and it'll clear everything to default. You disconnect the jumper, restart it, and you're good to go. Thank you for watching. I hope everyone else is excited as we are about the new design. We do apologize for the delay. We know a lot of people have been waiting for a while for these to come back into stock. I just didn't want to build this version again just because we had so many failures related to that power supply. And it was also really difficult for me to test and get ready to start selling. Like and subscribe and drop a comment if you have any questions. You can always send us a question through our website, peanutworkshop.com, or follow us on Facebook and send us a message there. Thank you. Bye.